So far, we have taken the coordinate system to be parallel to the edges of the paper. Selecting coordinate system in this way is completely arbitrary. In fact, we have infinite choices in selecting the coordinate system. The direction of the resultant vector does not depend on the direction of the coordinate axis chosen. Each coordinate axis just gives us a different way of describing the same vector. All produce the same magnitude and direction for a given vector. Rotating the axis changes the components, but not the vector. Also remember that we use right-handed coordinate system in all the examples. We will now discuss two special cases of vectors. Let us see how the components of a vector will change into special cases. Let theta be the angle made by a vector with positive x-axis. Case 1. When the angle theta equals 0. This means that the vector is along x-axis, or parallel to x-axis. In this case, the component notation of the vector changes as follows. V bar is equal to V cos theta times I hat plus V sin theta times J hat. Substituting the value of theta, which is equal to 0 degrees, we get V bar is equal to V cos 0 times I hat plus V sin 0 times J hat. Since cos 0 is equal to 1 and sin 0 is equal to 0, we get V bar is equal to V times I hat which means that the component of the vector along the y-axis is 0. Graphically, if we draw two lines, one from the tip of the vector and another from the toe of the vector onto y-axis, both the lines will be along the x-axis and meet at the same point, which is the origin in case the vector is along x-axis. So the y component of this vector is 0. We will now discuss the second case. Case 2. When the angle theta is equal to 90 degrees. This means that the vector is along y-axis or parallel to y-axis. In this case, the component notation of the vector changes as follows. V bar is equal to V cos theta times I hat plus V sin theta times J hat. Substituting the value of theta as 90 degrees, we get V bar is equal to V cos 90 times I hat plus V sin 90 times J hat. Since cos 90 is equal to 0 and sin 90 equals 1, we get V bar is equal to V times J hat, which means that the component of the vector along the x-axis is 0. Graphically, if we draw two lines, one from the tip of the vector and another from the toe of the vector onto x-axis, both the lines will be along the y-axis and meet at the same point, which is the origin in case the vector is along y-axis. So the x component of this vector is 0. Therefore we can conclude that, if a vector is parallel to either of the coordinate axes, the component of that vector along the other coordinate axis is 0. The components of a given vector will be different for different choices of coordinate axis, but the actual magnitude and direction of the vector does not change with the change in the direction of the coordinate axis. The choice of coordinate axis is always arbitrary. Therefore, you can often reduce the work involved in adding vectors by a good choice of axis. For example, by choosing one of the axes to be in the same direction as one of the vectors. Then that vector will have only one non-zero component. The point here is that we have a great freedom in choosing a coordinate system, because the relations among vectors do not depend on the location of the origin, nor on the orientation of the axis. This is also true of the relations of physics. They are all independent of the choices of coordinate system. That is the beauty of this subject.